Today we're going to learn one final way that we are going to solve quadratic problems, and they involve something called projectile motion. So you can label the top of page 126 projectile motion. That's where you're going to be taking these notes. Projectile motion basically means when I'm throwing something in the air. Think about throwing any object through the air. The path of the object ends up making a parabola. Think about football, baseball, whatever. Okay, and that object is going to reach a maximum. So this is our maximum height. And then when it crosses my x-axis, that is when it hits the ground. What my axes are, the y is usually height or distance, and my x-axis is usually time. Now we're going to look at the key words that I'm going to do so that I know whether I'm finding a zero or whether I'm finding the vertex. To help us out whenever we get one of these problems, the first thing we want to do is identify the variables. And we're going to put that in our parentheses. So we're literally going to write time, distance, or time and height, and that will help us. And then we're going to look for keywords. Our keywords tell us whether we're finding a vertex or zeros. We know we're finding a vertex whenever it says maximum, minimum, highest, or lowest. Those are our keywords telling us that we are going to be calculating the vertex. Our key things that tell us that we're looking for zeros is hit the ground or water, or fall to the ground or water. It's basically when you have something where your height is zero, that's telling me to find zeros. So what I'd like you to do is get your packet that you got in class today and turn to the back of the second page in the packet. You should have put this packet in the pocket on page 127. So flip to the second page and then turn it over and look at these problems with me. Number 1 said a ball is thrown in the air with an upward velocity of 44 feet per second. Its height h in feet after t seconds is given by the function blah. Okay, my first step before I even read the actual question is to write my ordered pair of what I am looking at in my problem. So how I do that is I want to look at what is in the place of x. What variable is in the place of x? Well, it's t, and t is representing time, or time in seconds. And then it says, instead of y, h, and h is height. So all of the xy pairs on my curve are going to represent time and the height at that time. Now I can read my question. In how many seconds? What does seconds have to do with? Time. So it's saying, at what time does the ball reach its maximum height. So maximum height is one of my keywords for the vertex. But my vertex is an XY pair, so then I need in how many seconds. That's telling me to look at the X coordinate of my vertex. So I'm going to find my vertex on the calculator, and then I'm going to write down whatever the X value is. Look at the second part of the question. What is the ball's maximum height? So once again, we have maximum height. That's telling me that I'm looking at my vertex. But now it doesn't care about the time, it cares about the actual height. So for number 1, all I'm going to have to do on my calculator is find my vertex, and for part A, write down my X value, and for part B, write down my Y value. Look at problem 2. The function y equals blah models the height y in feet of a stone t seconds after it is dropped from the edge of a vertical cliff. How long will it take the stone to hit the ground? Round to the nearest hundredth of a second. So I need to write my ordered pairs. What is in the place of x? T, which is seconds, so we're talking about time again. And what is in the place of y? Well, it's y, but what does y represent? Height. So my ordered pairs give me time and height. Okay, now I need to look for keywords. The function models the height, and blah, that's just telling me what the equation's about. Is dropped from the edge of a vertical cliff. Don't really care. How long will it take? Okay, so that's definitely asking for my X for it to hit the ground. Hit the ground tells me I'm looking for a 0. I'm looking for a 0. Anytime you see hit the ground, hit the water, fall to the ground, fall to the water, it's asking for a 0. So write down 0. And number 3, an athlete dives from 3-meter springboard. Her altitude y at a horizontal distance x can be approximated by the function blah. Both the altitude and the distance are in meters. So we need to write our ordered pair. What is in the place of x? Well, x, but it means something. The horizontal distance. I'm going to abbreviate that. Horizontal distance. And y is y, but it says altitude, which is really just height. So I have horizontal distance and altitude. Now let's read our part A. It says, how far has she traveled horizontally? What does horizontal have to do with x? So what is my x when she reaches her maximum altitude? And maximum is telling me I'm looking for my vertex. And because it said how far has she traveled, that means I'm looking for the x coordinate of my vertex. Part B says what is her maximum altitude? So since it says maximum, that means I'm dealing with my vertex. And since it actually wants to know what is my highest point, I need my vertex y. So now what I want you to do is go through the rest of the packet and identify, is it the vertex x? Is it asking for the vertex y? Or is it asking for the 0? We'll actually solve them in class, but you need to go through and know what it is you're looking for first. So finish that so I can check it in the morning. Thank you.